Hello class, my name is David Schwartz. I am your instructor for Math 1430. It used to be called Math 180, so it's Calculus 1. And today will be our first YouTube video, day 1, where we're just going to review some algebra. So I'm just going to review a few problems. And I'm teaching 3 sections of Math 1430. I've got an identical twin brother who also teaches math at UNM. He's teaching 1 section, which will also be on this same YouTube channel. His name is Doug Schwartz. He looks just like me. Let me introduce him to you all. Hello everyone, I'm Doug Schwartz, and I'm teaching 1 section, as my brother said. So he'll probably be doing most of these lectures, but I'll do some as well. So have fun in the course, everyone. Okay, let's get some of these problems now. All right, so I just have a few problems here, 4 of them altogether. And here's what I'm working with. You'll see this when you go to Learn under Announcements. This is my lecture notes for the first day. I'm just reviewing some algebra review problems. So I just picked 4 of these. You can see the rest on Learn with the answers all written out as you see them here. Okay, so the first problem I want to go over. So this is Math 1430, Day 1, Algebra Review. And as a reminder, besides my YouTube videos, you can also see videos on WebAssign under Resources. Those are very good. So be sure to check out those videos on WebAssign as well. And of course, that's where your quizzes, homeworks, and tests will be on WebAssign as well. Alrighty. And by the way, on the homework, you're allowed 5 attempts for each homework problem. So when you do your answer on WebAssign for homework, it will tell you if you're right or wrong. And if you're wrong, it will give you feedback. So you get 5 attempts for every problem. So try to do well on the homework, because, you know, it counts a good part of your final grade overall. And for the quizzes, you're allowed 2 attempts. And the first attempt, it will tell you if you're right or wrong, but does not give you feedback. So if you're wrong, try it again. And when you get to the tests, you're allowed 2 attempts, but really consider it as 1 attempt, because when you do your first attempt, it doesn't tell you if you're right or wrong on a test. So if you think you did it right, just move on. You're only given two chances, only because you might make a silly mistake. Like you get the right answer, but when you type it in, you make a little mistake somewhere. So that's why we give you 2 chances, primarily. So if you think you did everything right, just move on for the tests. Alrighty, so here we go. Day 1. Evaluate 4 times 9 raised to the 3/2 power. So it's tempting to go 4 times 9 is 36, but exponents come before multiplication. So what you want to do is first go 9 to the 3/2 power. So you want to do that first. And the denominator is called the root. If the root is 2, that means square root. So what is the square root of this base 9? And the answer is 3. And then with that 3, you raise it to the power of the numerator of your fraction. So again, the square root of 9 is 3, and then 3 to the 3rd power is 27. 3 times 3 times 3. So this really just becomes 4 times 27. So I'm going to write this is going to equal 4 times 27. So 9 to the 3/2 is 27. The square root of 9 is 3. And then this numerator, that's the power, because it's up high. Powers are high. Okay, and then 4 times 27 is 108. So there is our first answer, 108. It doesn't hurt to box your final answers. Okay, so we're done with our first problem. Here's the next problem. Simplify and write your answer in factored form. That means multiplying. So now we have a bunch of terms. We got 3 terms here. This is our first term plus the second term minus this third term. So this is called an expression. We want to simplify it and put it in factored form, meaning we don't want to see these pluses and minuses. Okay, so See, the second and third term, you really can't simplify at all. So the first part is to simplify this first term. These factors all get raised to the third power. This exponent says 3. So each factor, the 2, the p squared, and the q to the fourth, get raised to the third. So this is going to equal, so what is 2 to the third? That means 2 times 2 times 2, which is 8. And then a power to a power, by the rules of exponents, you multiply the powers. So 2 times 3 is 6, so I'm going to write p to the sixth. These YouTube videos will improve, will get better, improve as I move on, because I do have a tripod, and hopefully that will make things a little better. Okay, and then q to the fourth raised to the third, power to a power you multiply, so this becomes q to the 12th. So now we simplify that first term, and let me carry down the next two terms. Plus 3p to the fifth times q to the seventh minus 2p to the sixth times q to the 12th. Now try to make your exponents high. This 6 is a little low. Let me correct that. Yeah, that's an exponent, p to the sixth. Sorry for this glare of the lamp above. All right, and now what you want to do is look for like terms. So my first term is called a p to the sixth q to the 12th term. And look at this, the last term is also a p to the sixth q to the 12th term. So we can combine these terms. So what are 8 of them minus 2 of them? And the answer is 6 of them. So I'm going to write this is going to equal 6. And then you keep that common factor of p to the sixth q to the 12th. So that takes care of the first and third terms. So now all I have left is this middle term. So I'm going to rewrite that. Plus 3p to the fifth q to the seventh. So this would be simplified. Normally I would accept that as a final answer. But we want to follow directions. It says write your answer in factored form. This is not factored form because of that plus sign. So what you want to do now is pull out a GCF, a greatest common factor for these two terms. Because when I pull out a GCF, I'm going to have factored form. So this is going to equal. So first look at the numbers. What's the greatest common factor for 6 and 3? The answer is 3 because 3 goes into both of them. So pull out a 3. And then I see here I have a p to the sixth. Here I have a p to the fifth. So the GCF is p to the fifth. You pick the lower exponent because p to the fifth goes in both p to the fifth and p to the sixth. So I'm going to write p to the fifth, pull that out. That's part of my GCF. And then I got q to the 12th and q to the 7th. So the GCF, I'm going to pull out q to the 7th, the lower exponent. So that's one factor. Times, so use parentheses, and then to get your next factor, you see what's missing for the first term and then the second term. So I pulled out a 3, so I'm missing a 2, because 3 times 2 is 6 for the first term. So I'm going to write a 2. And then p to the fifth I pulled out, but I need p to the sixth. So we're just 1 away, just 1 p away. So just write a p. As a check, isn't p to the fifth times p to the sixth? Because if you have the same base, you add the exponents. P is like p to the first. So that would be p to the sixth. I took out 7 q's, but we need 12 q's. So we're missing 5. So let's write q to the fifth. Boy, this light is annoying. Sorry about that. Q to the fifth. So that takes care of the first term as a check. Isn't 3p to the fifth q to the seventh times 2pq to the fifth exactly that first term? 6p to the sixth q to the 12th. Yes, checkaroo. And then write plus. And now for the second term, what am I missing? Well, the 3 we already pulled out, so that we don't have to worry about that 3. The p to the fifth I've already pulled out. And q to the seventh I've already pulled out. So what must I write here? Everything is accounted for. You have to write a 1. Because isn't 3p to the 5th q to the 7th times this 1 going to be exactly that? Yes. So this is my final answer. It's in factored form. Everything is multiplied. So it's 3p to the 5th q to the 7th as my first. You can think of this as like your first factor, even though it's really 3 factors there. Times, and then in the parentheses, this is my second factor. So these two terms are in parentheses, so this whole thing becomes a factor. So that's my final answer right there. 3p to the 5th q to the 7th times 2p q to the 5th plus 1. Let's move on to the next problem here. Determine the linear function g of x so that g of 1 is equal to 10 and g of negative 5 is equal to negative 10. So this is function notation. When I input 1, I'm going to output 10. Your input is like your x, your output is like your y. So think of g of 1 equals 10 as this ordered pair, which will be on your linear function. 1, 10. And if g of negative 5 is negative 10, when I input negative 5 into my function g, I output negative 10. So this is like my x, this is my y, x is input, y is output. So think of this point on the line. This point will be on the line. Negative 5, negative 10. So whenever you have 2 points on a line, you can write the equation of the line. And to write the equation of a line, you need a point and a slope. The point we got 2 points. All you really ultimately need is 1 point. So I'm going to pick this easier point since there's no negatives. And then to find the slope of the line, I'm going to use this formula, which I'll write over here. Slope is designated by m. So m equals the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's going to equal, so y sub 2 is like my second y coordinate minus my first y coordinate. So here's my 2 points. I'll call this my first point, this is my second point. So y sub 2 I'm going to think of as negative 10 and y sub 1 as 10. Those are my y coordinates. So I'm going to go negative 10 minus 10 over the difference of my x's, x sub 2 minus x sub 1. So my second point, there's my x sub 2, there's my x sub 1. So negative 5 minus 1. Negative 5 minus 1. And then you want to simplify the numerator as negative 20 over the denominator is a negative 6. 2 negatives in division make a positive. 20 divided by 6, let's reduce it to cut them each in half. 2 goes into each of them. So that's going to be 10 thirds. Let me write that down. It's a positive 10 thirds. That's my slope. Okay. Let me just check something out here. I'm doing number 13. Yeah. So far this looks good. So now that I have my slope, and by the way, you could have gone for your slope, instead of negative 10 minus 10 over negative 5 minus 1, you could have started with this point first. So you could have gone 10 minus a negative 10 over 1 minus a negative 5, and you would get the same answer. Okay, so I got my slope, and I'm going to choose this point, like I said, because it's easier to deal with since there's no negatives in it. But I could have chosen this point, and I would get the same equation. Okay, so now that I have a point and a slope, remember all points are x comma y. So think of 1 as x and 10 as y. So next step is to write the equation of the line. You can either write in point-slope form or slope-intercept form. I'm going to do slope-intercept form because that's what most of us do. Y equals mx plus b. So I know my line can be written in this form. M is the slope, which is 10 thirds. X and y, I'm going to choose x as 1 and 10 as y. So for y, because right now I know everything but b, so let's figure out b. So for y, write 10. M is 10 thirds times x, which is 1, plus b. So 10 thirds times 1 is just 10 thirds. So subtract 10 thirds to each side. I want to get a common denominator. So what's 10 minus 10 thirds? Think of 10 as 10 over 1. So 10 over 1 minus 10 thirds, because this is just 10 thirds. Subtract 10 thirds to each side to get b by itself. So 3 is my common, this is a 3. So 3 is my LCD. So multiply 10 over 1 by 3 over 3. So another name for 10 over 1 by multiplying by 3 over 3 is 30 thirds. So what's 30 over 3 minus 10 over 3? 20 over 3. So this implies b is 20 thirds. So I've got my b. So now we're 95% down. So the equation of the line, going back to y equals mx plus b, what we want to do for our final equation of the line is keep x and y as x and y. Just fill in for m and b. So here's the equation of the line so that g of 1 is 10 and g of negative 5 is negative 10. I'm going to write y equals m is 10 thirds, x we're just going to call x, and then plus b. b is 20 thirds, so plus 20 thirds. And that's the equation of the line. But since it does say determine the linear function, let's write function notation. What's another name for y when you have a function? F of x. So for the final answer, let's write function notation. So in place of y, I'm going to write f of x equals, sorry, this is a little sloppy here. Again, my videos will improve. Okay, and then I'm going to rewrite the 10 thirds x. Put the x right in the middle of the fraction. It looks nicer that way. Plus 20 thirds. And I'll put a little block. Done. Done. There's my final answer. F of x equals 10 thirds x plus 20 thirds. Okay, and finally, for the last question, this goes quickly. Suppose h of x is this square root function. What is the domain of this function h? So the domain means allowable inputs for x. So with square roots, the expression x squared plus 5 cannot be negative. So whenever you want to find the domain of a square root function, whatever's inside the square root, to make any sense at all, must be greater than or equal to 0. Subtract 5 to each side. So now I get x squared is greater than or equal to negative 5, because I want the x squared by itself. When I subtract 5 from each side, I get x squared is greater than or equal to negative 5. X squared plus 5 is greater than or equal to 0. So this is always going to be true because the smallest x squared can be is 0. You can even you don't have to write this line if you don't want to, but you can if you want. But isn't x squared plus 5 always going to be greater than or equal to 0? Because if x is negative, x squared is positive. A positive plus a positive is going to be a positive greater than 0. If x is 0, 0 squared is still 0 plus 5 is 5. So in fact, x squared plus 5 will always be greater than or equal to 0, which means there's no restrictions for x. No matter what I input for x squared plus 5 will never be negative. So the domain is going to be simply all real numbers, negative infinity to infinity. And we're done. Thank you. Bye-bye. Ciao.